Okay, so like I said, today we're going to do something very interesting, which is normal distribution. Okay, now how many of you have done this already in school? Not that I'm counting on that you know this. I mean, not that we're not doing this from scratch. We will be doing it from scratch. Don't worry about it. Yes, Fatma, you've raised your hand. Do you have a question?
Sir, I sent you a question on the WhatsApp about less than 10. So you said the opposite will be at least 10. So how would we know that what will be the opposite exactly?
Less than 10 का क्या मतलब है? Less than 10 means 9, 8, 7, 6, right? So what is
More than 10.
opposite of, sorry?
Shouldn't it be more than 10? The opposite.
No, more than, then what happens to 10? Where does 10 go? 10 gets excluded, right? 10, so we have to accommodate that also. Less than 10, okay, just answer my question. Less than 10, in less than 10, is 10 included? Yes or no?
No.
No. In greater than 10, 10 included?
No.
No. Then what happens to 10? So can I say that greater than 10 is opposite of less than 10? Can I still say that? Can I say, sorry?
But sir, more का opposite तो less.
देखो, I agree. Literally, yes, more का opposite is less, okay? But we're talking mathematically over here, okay? Now, if I say less than 10, how many numbers fall in that range? Or where do numbers start from? So let's look at it that way. If I say less than 10, can you tell me all the numbers that are less than 10?
0 to 9.
0 to 9, okay? Basically starting from 9 and then 8, 7, 6, so on and so forth. If I say more than 10, okay, now remember, we're speaking mathematically over here. If I say more than 10, can you tell me all the numbers that are more than 10? Can you tell me where they start from and like just give me an idea of 3, 4 numbers that are more than 10?
11.
11, 12. So what happens to 10? Where does 10 go? So now mathematically, can I say that more than 10 is exactly the opposite of less than 10? Can I say that?
You can, because less than 10 maybe we weren't considering 10 itself.
अच्छा चलो एक काम करते हैं. Okay. If I say that you don't get an A if you score less than 80%. Okay? If I say that you don't get an A if you score less than 80%, then can you tell me what will be the range of A is going to be?
80 and more.
How did you figure that out? Why did you say 80? I didn't say that. But you figured it out, right? Because if less than 80 does not get you an A, then you figured that the opposite of less than 80 would be 80 and more, which means at least 80. That gets you an A. सोचने वाली बात है ना. अब अगर कोई कहे, let's think of it this way. Let's say somebody scores 80%, okay, and they don't get an A. Is that fair?
No.
That's not fair. Why? Because you don't get an A if you score less than 80%. That naturally means, abhi hum English we're not looking at it literally, we're looking at it mathematically. Okay, that naturally means 80 and above gets you an A. Okay, does it make sense now?
Yes, so if the less than 10 doesn't include 10, its opposite should include.
Yeah, exactly.
Okay. Thank you.
Alright, you're welcome. So could you tell what is probability and random variable? Okay. So basically, what we do through binomial distribution, what we do through geometric distribution, and what we do through normal distribution is what? Question for you guys. What is it that we do through binomial distribution, through geometric distribution, and through normal distribution? Like, what's the whole purpose? What's the central theme? Exactly. Define probability. Okay? Define probability. That's what the objective is. Now, why do we have so many kinds of distributions? That's because we can't treat every variable the same way. Okay? Some variables are discrete. Like, for example, if you're interested in the number of days a flight is late. So a flight is late maybe 1 day, 2 days, 3 days. So these are discrete values. Okay? There's no value that's such as 1.5, 2.5. You can't say that A plane is late 2.5 days out of 7. Doesn't make sense. Okay. If you're rolling a die and you're interested in a certain outcome, that means that outcome will happen discrete number of times, maybe once, twice, 3 times, 4 times, 5 times. Okay. So whenever whenever we're talking about discrete outcomes, it's either categorized as binomial distribution or geometric distribution. Okay, and we know how to distinguish between the two. In binomial, the number of trials are fixed, they're integers. In geometric, the number of trials are not fixed, and we keep on going till a certain desired outcome, or till a desired outcome is obtained. Okay, but what about normal distribution? Where does normal distribution come in? So let's read what I've written over here. It's a type of distribution symmetrical about the mean. Now, more about this in a minute. This means that most of the values are either equal to the mean or fall close to the mean. Again, more about this in a minute. For example, height, weight, grade, salaries in an office. I'll explain why these variables follow a normal distribution. Okay. Now let's read it further. The random variable is called continuous random variable because it can take any value on the number line, unlike discrete random variable such as binomial and geometric, where values can only be whole numbers. Okay, so for example, let's take weight. If let's say we take two values, let's say 60 and 61 kg. Okay, 60 and 61 kg. Can I say that somebody will either be 60 kg or 61 kg and nothing in between? Is it safe to say that? Yes or no? No, obviously it's not safe to say that. Why? Because weight, we know, does not have discrete values. It will have continuous values. It's possible that in between 60 and 61 you have 10 or hundreds of values, 60.01, 60.05, 60.5, 60.75, goes on forever. Okay, we're not going to have discrete values over here. Same goes for height. In between 6 feet and 7 feet, can I say that you can either be 5 feet tall or 6 feet tall? Can I say that? Does that make sense? Can we categorize people as 5 feet tall and 6 feet tall? Can we do that? No, of course not. There's got to be a range. Okay. And the reason why we have a range, there's got to be so many values in between this range, and the reason is because it's a continuous variable. Okay, in between you will have multiple values. Okay, now, so let me tell you something about normal distribution. Okay, before I give you an explanation about the concept, let me just tell you something a bit about this topic. It's technical. Okay, it will take a while for you to completely get the hang of it, so just don't give up in between. Let me finish the concepts, do lots of example questions, only then will it make sense to you. And in between, there will be occasions where I will be writing down some rules. You will have no idea how to use those rules if you're doing it for the first time. Okay, but then once we look at some example questions and we apply those rules, you will understand how it works. Okay, so if you don't understand something, it's okay, it's completely normal. Once we're done with like plenty of example questions, everything will just fall into place. Okay, so just a disclaimer. And this is normal distribution is going to be the first difficult topic that we're going to do. Okay, so far the topics that we've covered have been fairly easy. So this is, it's uphill for a while from here. Okay, so if we talk about height of people, or if let's say we talk about weight of people, or let's say we talk about grades, all right, or salaries or shoe sizes. Now you will notice that these values follow a certain pattern. Okay. Now, generally, when you walk around, when you meet people, has it happened that on a given day, you come across people who are extremely tall? Has it ever happened? Or on a given day, you come across people who are extremely short? Has that ever happened? That, today or on a certain day, you were like, today I only saw tall people on the road, or today I could only see short people on the road. Has that ever happened? I'm sure it hasn't. Why? Because height, just like weight and grades and salaries in an office, they follow a distribution which is symmetrical about the mean. What does that mean? That means most of the people that you will meet, you will notice they have an average height, okay? And then you have your outliers, okay? So most of the people that you meet will have their height, their height is going to be either equal to or close to the mean. That doesn't mean that you don't have exceptionally tall people, and that doesn't mean that you don't have exceptionally short people. You obviously have exceptionally tall and exceptionally short people. Okay? Just like that, if we talk about salaries in an office, is it possible that every employee is a well-paid employee? No, of course not. Yes, you have exceptions. Is it possible that every employee is not a well-paid employee at all? No. You will have some employees who are not so well-paid, depending on the kind of job that they're doing. But most of the salaries that you will see will fall around the average salary. Okay, and then you will have some people who are on the other side of the curve, one extreme, and some people who fall on the other extreme of the curve. So look at this curve to understand what I'm saying here. So imagine this. On the x-axis, we have salaries, okay, and on the y-axis, we have frequency, okay. So you can see how this works here. So on the x-axis, we have salaries, and on the y-axis, we have frequency. So you can see that most of the people are withdrawing an average salary, okay, and majority of the data, okay, majority of the people have a salary that's either equal to the mean or close to the mean. And just so you know, in a normal distribution, the value that you have at the center is equal to the mean. Okay, the value that you have at the center is equal to the mean. So this gives us an idea of the salaries that we have in this office. Now, that doesn't mean that you don't have exceptionally well-paid employees. Of course you do. Okay, this is what we consider as outliers, and that also doesn't mean that you don't have exceptionally low-paid employee. Of course, that's also possible. They are considered outliers of the other extreme. Okay, just like that, when you give a test, does everybody end up with A's and A stars? Does that happen, that after a test or after an exam, everybody ends up with an A or an A star? Yes or no? Even if the test is extremely easy, it still doesn't happen. Okay, and does it happen that everybody fails the test? No, it doesn't. Okay, why? Because this distribution also follows a certain pattern, something like this. Okay, so this is an example of SAT scores. All right, if you're not aware of what SAT is, it's a standardized test, okay, consisting of math and English. So it's out of 1600. Now you can see that not many people score 1600. Okay, you have exceptions, but majority of the people score an average score or a score that is very close to the average. Okay, and just like that, not many people fail the test, or not many people score 700. You have fewer people who score exceptionally low and fewer people who score exceptionally high. Okay, and just like that, if let's say we take shoe sizes. Now, not everybody has exceptionally small feet, and at the same time, not everybody has exceptionally large feet. Okay, majority of the data is somewhere in between the mean. Okay, so the mean, remember, is at the center. All right, so majority of the data is either, or majority of the shoe sizes are either equal to the mean or close to the mean. That's what it says. A type of distribution symmetrical about the mean. So if let's say somewhere over here, this is the mean. Now you can see that this data is symmetrical about the mean. Think of it as a quadratic curve, although it's not exactly a quadratic curve, but think of it that way. So it's kind of like a quadratic curve, symmetrical about the turning point. So here also you can think of this as your mean, and you can see that the data is symmetrical about the mean. Okay, now, so there are a couple of properties regarding a normal distribution curve. Okay, so let's write down those properties. So this is basically a continuation of this. Okay, so we collected SAT scores from, let's say, 3000, or the total number of students is irrelevant, but let's say that we've collected SAT scores of a certain number of students. Symmetrical meaning linearly changing? No, symmetrical meaning means mirror images. Okay, so this half of the curve is a mirror image of this half of the curve. Okay, I'll explain what I mean by that. Okay, so basically, the graph of a normal distribution has a certain pattern. Okay, and we find this pattern throughout. Just like we find a pattern with values such as salaries, normal shoe sizes, and SAT scores, the graph that we get has a certain pattern as well. Okay, so let's write that down. The graph of a normal distribution is always, okay, so I'm going to write down a couple of key points. Bell curved. Okay, so these curves are called bell curved. Any idea why? Any idea why they're called bell curved? It's kind of self-explanatory, by the way. The shape, exactly, because they look like a bell. Okay, they look like a bell. That's why we call them bell curved. Okay. Point number 2, and that is they're centered around or centered at the mean. That means the mean naturally falls at the center. Okay, just like we saw earlier, that if let's say you start collecting data of the weight of people, then you will notice that the mean ends up right at the center, and then most of the data is either on the right side or left side of the mean, and then you have fewer data on one extreme or on the right side of the mean and fewer data on the left extreme of the mean. Okay. Key point number 3, mean equals to the median, which is equal to the mode. Okay, now let's understand this. Maybe I have seen this on datasheet. Yeah, it's possible. So if I ask you to tell me the mode of this data, you'll notice that the mode, what is the mode, by the way? The mode is the score that most people get, okay, or the most frequently occurring value. So in this case, what's the mode? The mode is going to be 1150. In this case, what's the median? The median will also be 1150. What's the median? Median is the value that is right at the center. So 1150 is the value that's right at the center. That means the mean is equal to the median is equal to the mode. When does this happen? This happens when you're looking at a variable which is normally distributed, such as weight, height, grades, etc., etc. Okay. Then, okay, now we're going to get a bit technical, but don't worry, this will all fall into place. 68% of data is within 1 standard deviation of the mean. Okay, now I'll explain what I mean by that just a minute. Key point number 2, 95% of data is within 2 standard deviations of the mean. Okay, this is a pattern that you will find every single time if you're looking at a normal distribution. And key point number 3, 99.7% of data is within 3 standard deviations of the mean. Achha, just so you guys know, there are some symbols that we will be using, so I'll write those down. The symbol that we use for mean from now on will be mu, okay, in this chapter, all right? And another symbol that we use for standard deviation, this is something that you guys know already, it's this sigma, okay? And variance, what's variance? Variance is the square of standard deviation, so it's sigma squared, okay? Now, what do I mean by this? 68% of data is within 1 standard deviation of the mean, 95% of data is within 2, and 99.7% of the data is within 3 standard deviations of the mean. Does anyone understand what I mean by this? I will explain, but I want to see what your understanding is right now.
So standard deviation would mean these different blocks of the, like जिस तरह से इसके ऊपर लिखा हुआ percentages लिखी हुई हैं 2.35, 13.5. So 99.7% of the data जो है वो consist करेगा of 3 blocks.
Yes, okay. So I'll explain. What you said is mostly correct, okay, but obviously I still have to explain it. Okay, so just a minute, let me sort this out. Okay, so this curve that you're looking at, okay, what is this representing? This is representing SAT scores from students in a new test preparation course. The data follows a normal distribution with a mean score of 1150 and a standard deviation of 150. Okay, so this right here at the center is what? Is the mean, okay? And what's mean plus standard deviation? 1300. Why is that? 1150 plus 150 is equals to 1300. So the score 1300 is basically 1 standard deviation away from the mean towards the right. Okay, just like that, what is mean minus standard deviation? Mean minus standard deviation will be 1150 minus 150, which is 1000. Okay, so these two scores, 1000 and 1300, are both within 1 standard deviation of the mean. And what did we learn? We learned that 68% of the students, because this is normally distributed, okay, so it's guaranteed that 68% of the students will have a score within 1000 and 1300. Okay, why can we say this? Why are we in a position to say this? Because this follows a normal distribution. All right. Okay, not just that. Another thing that we can say for sure is that 95% of the data will be within 2 standard deviations of the mean. So what's the mean? The mean is 1150. What will be 2 standard deviations away from the mean? 1450 and 850. So 95% of the students will have a score in between 850 and 1450, guaranteed. Again, why can we say this? We can say this because this is following a normal distribution. All right, and last but not the least, 99.7% of data will be within 3 standard deviations of the mean. Again, guaranteed. All right, so that means 99.7% of the students will have a score that's in between 700 and 1600. Okay, this is basically what we are able to determine once we realize that a certain data is normally distributed. Okay, yeah, that's all the data. Okay, so obviously all the data will be within 3 standard deviations from the mean. Okay, all right, now, so the reason why it's not 100%, well, in this case it's got to be 100%. Okay, now these are, just keep in mind that these are approximations. Okay, like 68 is not exactly 68, it's 68.3 something. Okay, 95 is also not exactly 95, it's 95 point something. Okay, so this is just an approximation, keep that in mind. Now in this case we can say that 100% of the data will obviously be within 700 and 1600, because we know SAT score won't be less than 700, and it won't be more than 1600. But normally we'll be dealing with variables that don't really have an upper limit and don't really have a lower limit. Okay, so we don't really define an upper limit and we don't really define a lower limit. That's why we say 99.7% of the data will be within 3 standard deviations of the mean. Okay, you'll understand once we get to a question where we have to deal with that. Okay, now moving on. If this is all confusing to you right now, it's okay, nothing to worry about. Things will fall into place. Now remember the whole purpose. The whole purpose of standardizing it is so that we can calculate probability. Okay, so keep this at the back of your mind, that once we know that a variable is normally distributed, then there are some certain rules that we follow in order to calculate probability. Have you guys heard of z-table? Have you guys seen a z-table? Those of you who have done this would know, but those of you who haven't, have you heard of a z-table? Okay, no, that's perfectly all right. Those of you who have, that's great. Okay, so basically, since every variable that is normally distributed follows a certain pattern, what we do is we standardize it further. Okay, what we do is we convert it to something called standard normal distribution. Okay, so let's write this down. Okay, since every normal distribution follows a specific pattern, it can be converted to standard binomial, sorry, not binomial. If I ever end up using the word binomial, please note it's a mistake. Standard normal distribution. Okay, and why do we do this? Where the area under the curve is equal to the probability. Okay, and I'll make an arrow over here and write Z table. Okay, so we use something called Z table. All right, now what do I mean by this? Let me explain. Okay, so here are the SAT scores. We do this so that we can calculate probability. Okay, so here are the SAT scores. Now, because every normal distribution follows a specific pattern, like I've written, what we do is we convert it into standard normal distribution. Okay, now how is standard normal distribution different from regular normal distribution? Well, in standard normal distribution, what we're recording is we're recording the number of standard deviations from the mean. So the mean is considered 0, and 1300, as you can see, is one standard deviation from the mean. So here we write 1. 1450, 1450 is two standard deviations from the mean. So here we write 2, and so on and so forth. And on the left hand side, we do the same. 1000 is one standard deviation less than the mean. So that's why we write -1. 850 is two standard deviations less than the mean, so that's why we write -2. Okay, now how does this work? How does this help? So let's first of all see how do we convert and how we find the probability. So when we're talking about normal random variable, before we've converted it, this is what it looks like. Normal random variable. Okay, so X is the normal random variable which follows a normal distribution, or you can say is normally distributed with mean, mu, and variance, sigma squared. Okay, remember this mu is for mean and this sigma squared is for variance. All right, and then when we convert it to standard random variable or standard normal distribution, here's what we do. Standard normal variable, the values from X are converted to Z. Okay, we find Z values. How do we do that? We'll learn in a minute. And in a standard random variable, this too is normally distributed. Yes, they look the same because they're both normally distributed, but here the mean is 0 and the variance is considered 1 squared, or simply 1, because the square of 1 is 1. So we still write it as 1 squared, because remember, whenever you're defining a normal distribution, you write the mean and the variance. Okay, now the question is, how do we do this? How do we convert a normal random variable to a standard random variable? Okay, there are some certain rules that we follow. Okay, what are the rules? Let's write that down. So the first thing that we do is we find something that we called the Z score. The Z score of the value of X. Now, what is the purpose of Z score? The purpose of Z score, like for example, this is the value of X. Okay, this X has now turned into 1300 has now turned into 1. What does that mean? That means the Z score of 1300 is positive 1. Why? Because 1300 is one standard deviation away from the mean. Just like that, the Z score of 1450 is 2. Why is that? Because 1450 is two standard deviations away from the mean. But we won't always have values that are 1, 2, or 3 standard deviations away from the mean. What if we have a value, let's say 1200? How do I decide what the Z value of 1200 is? For that, we have a formula. Okay, so find the Z score of the value of X. And how do we do that? By using the following formula. And what's the formula? I'll write down the formula. Z is equals to X minus mu upon the standard deviation. Okay, now what's X? X is basically the individual value. Mu, as we saw earlier, is the mean. And what's sigma? Sigma is the standard deviation. Okay, not the variance. Variance is sigma squared. Sigma itself is standard deviation. Okay, now what's the purpose of finding the Z score? The purpose of finding a Z score is that it tells you how many standard deviations away from the mean each value lies. Okay, that's step 1. Then comes step 2. Step 2 is After we've determined the z value, then what we do is we don't just leave it there. We find out its p value. P, or something that we are going to use, a word that we're going to use, phi. Okay, how do we find out the phi value or the p value? We will find out the phi value or the p value by looking at that table. Okay, so let's write this down. Find the p value of the z-score from the z-table. Okay, now once again, I'll give you the disclaimer that I gave earlier. I'll give it again. I know a lot of this at this point doesn't make sense. Okay, that's perfectly all right if it doesn't make sense. Things will fall into place. Normal distribution by nature is a confusing topic. The theory of it, okay, but once we apply it practically, you will see all the theory will also make sense. Okay, so basically what we're doing is we're finding out the phi value of z, and what that is equal to p. Okay, so just so you know what these symbols mean, this is basically phi. P is basically the area, which is not just the area, but the area under the curve is actually equal to the probability. No, you don't have to retain all the, dekho, this theory, like I said, will make a lot of sense once we look at an example. Okay, so just hang in there, Step number 3 is the p value. That means after you've read the table, the p value represents the probability up to that value of z. Okay, that is the probability of z being less than or equal to z is what p represents. Okay, it represents up to or less than. Step 4, this is not really a step, this is just a note. So what if you have to find out the probability of greater than? So let's write that down also. To find the probability of greater than z, we subtract phi of z from 1. Now, any idea why we're subtracting from 1? This is not related to normal distribution, by the way. Any idea why we're doing this? Yeah, total probability is always 1. Okay, so total, if you already have the probability of less than and you want to find out the probability of greater than, so we subtract it from 1. Okay, so I'll make another note that if you want to find out the probability of z being greater than z, for that you find out the probability of less than or equal to and subtract it from 1. Okay, now here's what we're going to do. All this theory, we're going to pause it for a minute. Okay, and we are going to, because this theory will make sense once we learn how to read the z table. Okay, so this theory will make sense, I repeat, once we learn how to read the z table. Okay, and this z table will be provided to you in the formula sheet. Okay, the formula sheet MF19 that you get with P1, you will be given this formula sheet. And once again, disclaimer, if you're looking at the z table for the first time, you will freak out. Okay, so here it is. This is what it looks like. Now, how do we use this? Now, before we learn how to use this, let's understand what this is really representing. Okay, so this is the bell curve of standard normal distribution. Why? Because you can see the mean is 0. Okay, and all the values that you have on the right side are basically more mean plus certain standard deviations. On the left side, it's mean minus certain standard deviation. Okay, now this value of, let's say we saw earlier that 68% of the data lies within one standard deviation of the mean. Okay, now if the standard deviation is 0, okay, if the standard deviation is 0, that means we're talking about the mean. Okay, which value will have standard deviation 0? The mean itself will have standard deviation. Okay, so here are your z values. Vertically, you find that you have your z values, okay? Now let's look at the corresponding value of 0.00. Okay, what is the corresponding value of 0.00? It's 0.5. Now the question is, what does this 0.5 actually represent? The 0.5 actually represents that the amount of data that, or the probability of a value having 0 standard deviation or being equal to the mean or being equal to up until the mean, less than or equal to the mean, is 0.5, or we can say 50%. Okay, and we can see that since 0 is right at the center, that means the area of this curve actually is 0.5, and this area is also representing what? This area is also representing the probability. Okay, now let's say I want to find out the probability of a value being less than 2 standard deviations away from the mean. Okay, I want to find out the probability that a value is less than 2 standard deviations, positive 2 standard deviations away from the mean. That means, what is it that I'm interested in? I want to find out the probability of z being less than or equal to 2. This is what I'm interested in. Now the question is, how do we do that? Now we will learn how to read this table, but for now I will tell you what the probability is, and I'll tell you what it actually represents. So 2.0, where do we find 2.0? Here is where we find 2.0. Now what do we get? What's the corresponding value of 2.00? It's 0.9772. Now what does that mean? What does 0.9772 mean? 0.9772 means that the probability of a value being less than 2 standard deviations away from the mean is 0.9772. Okay, now this was just an overview. Let's look at it in detail as to how we read the z table. Okay, so now we're gonna see in detail how the z table is read. So first let's write down some theory, and then we will do some example questions. Okay, won't that be different depending on every data? Okay, that's a good question. Won't it be different depending on every data? That's the beauty of it. Once we convert it to standard normal distribution, then we use the z. We can use the z table to find the probability. Okay, the z value will be different, and how do we get the z value? We will get the z value by taking the data and converting it to standard normal distribution. Okay, now because देखो, if a variable is randomly distributed, all right, if a variable is randomly distributed, then this rule always follows. Okay, this rule always follows that 68% of the data is within 1 standard deviation of the mean. That means 68% of SAT scores will be within 1 standard deviation of the mean. 60% of shoe sizes will also be within 1 standard deviation of the mean, and 68% of the salaries will also be within 1 standard deviation of the mean. Okay, so once you realize that a certain data is normally distributed, that means you can standardize it, and the purpose of standardizing it is so that we can find the probability. Okay, yes, the values will be different. Okay, you know, salary will have a different unit, shoe size will have a different unit, SAT score is a different unit, which is why what do? We first standardize it. Okay, and the whole purpose of using this formula is so that we can standardize it and then use it to find probability. Okay, does that answer your question? How to read the z table. So phi of z equals to p. Okay, and what's z? Z is basically the z value, or we call it the z score. And this p is basically the area under the curve, which is equal to probability. All right, now let's say you want to find out the probability. Now here's an example. Okay, let's say you want to find out the probability of z being less than or equal to 1.5. Okay, what does that mean? That means you want to find out phi of 1.5, or you want to find out the p value of 1.5. Okay, so these values that you're looking at, let me clear it. These values in this column, these are all your z values. Okay, and all these values, all these values. Okay, these are all your p values. Okay, so if I want to find out phi of 1.5, okay, or if I want to find out the p value of 1.5, how will I read this table? So 1.5, how many decimal places do we have? We just have one decimal places. And notice that in this column we have values correct to one decimal place only. So we'll start from here. Here's z starting from 0.0. We'll keep on going, 1.5. Now what's the decimal after 5? Since we don't have a decimal after 5, that means it's 0. Whether we say 1.5 or 1.50, same thing. Okay, so what will be the p value of 1.5? It will be 0.9332. That means phi of 1.5 is equal to 0.9332. Okay, this was one example. Now what does this mean? This means that what is the probability that a value falls within, or a value is less than 1.5 standard deviation from the mean? The probability is 0.9332. Okay, so I want you to keep in mind how we're reading the table and at the same time what our answer is representing. The probability that a value is less than 1.5 standard deviation away from the mean is 0.9332. Okay, let's do another example. Let's say you want to find out the probability of a z value being less than or equal to 2.52. What does that mean? That means you want to find out phi of 2.52. Okay, so let's see how we can find out phi of 2.52. So we start from here. Okay, here is where we see the integer and the first decimal. So 2.5, that's right here, but this is 2.52. Okay, what do we have over here? Here we have 2.52. Now the value of 2.50 is 0.9938. Okay, now how do I know this is 2.50? Because now you're looking at these columns. Okay, now you're looking at these columns. Now since I want to find out the value of 2.52, these are all the values where the first decimal is 2.5. But like I said, since I want to find out the value of 2.52, let's see what is the value where the second decimal is 2.5. So where the second decimal is 2. So 0.9941 is the correct answer. Okay, now once again, why 0.9941 the phi value or the p value of 2.52? Because you start from this column 2.5, this is the max you can take from this column. Now for the next decimal, you will have to find out the corresponding value that is in the same row as 2.5 and in the same column as 2. Okay, so this column, remember, is for your second decimal place. Okay, so this column is for your second decimal place. In the first column, you have this row actually. This row is for the second decimal place. The first column is for values correct to one decimal place, but if you have a second decimal place, then you make use of this row. So 0.9941 is the phi value of 2.52. 0.9941. Okay, let's do another example. Let's say you want to find out the probability that z is less than or equal to 1.57. Let me make this slightly tricky. 1.579. Okay, how many decimal places do we have here? We have 3 decimal places. Okay, it's 1.579. All right, let's clear this. So 1.5, that's right here. 1.57, that's right here. 0.9418. Okay, but we want to find out the p value of 1.579. Now where do I take the corresponding value of 9 from? So notice that here it says add. Okay, now this is the first decimal. Okay, 1.5. For the second decimal, we look at this row. Okay, so 0.9418. Now we carry on. Because it's not 1.57, it's actually 1.579. So in order to find out the corresponding value of the third decimal, we carry on, we see where 9 is, So from this column and from the same row as 1.5, we take the corresponding value, which is going to be 11. And then what we do is, where do we add this 11? We add this 11 in the last two decimal places. Okay, so here you have to work it out. 0.9418 0.9418 was the p-value up until 1.57. But because you have a 9 at the end and the corresponding value of 9 is 11, so this 11 you add in the last two digits. So what do you get? You get 9549. So 0.9459 is the correct answer. And what does this mean? This means that the probability that the z value is less than 1.579 standard deviation away from the mean is 0.9459. Okay, now I'll explain this again. Okay, take as much time as you have to in order to understand how the z table is read. Okay, no, it can't be more than 3 decimal places. Don't worry about that. If it is, then we only stick to 3 decimal places. Okay, so as I was saying, take as much time as necessary in order to understand how we work with the z table, because in normal distribution you will be working with it. Okay, so we want to find out the phi of, or the p value of 1.579. Okay, so for the integer and the first decimal, we use this column. So here's 1.5. Okay, now for 1.57, we stop when we reach 7, which is 0.9418. But we have to find out the p value of 1.579. So how do I know what to do with the 9? So notice that it says add. Okay, and since it's 1.579, I will carry on and find out the corresponding value of 9, which is 11. Okay, and make sure that you're in the same row as 1.5. Okay, make sure you're in the same row as 1.5. All right, and what's the corresponding value? It's 11. So now you're going to add 11. Whatever digit that you have to add in the end, you do it in the either the last one digit or the last two digits. Like for example, if it was 6, I would have added 6 to the last digit. Okay, but since here we have 2 digits, so I'll add 11 to the last 2 digits. Okay, so that's why we add 11, and you have 0.9459. Okay, now any questions? If yes, feel free to ask. I'm going to give you, we're just putting the theory on hold for a minute. Okay, we're just putting the theory on hold for a minute. Why? Because we want to get the hang of reading the z table. Okay, so let me do a few more examples. Yeah.
Sir, थोड़ी सी मुझे confusion हो रही थी कि like what's the purpose, हम find out क्या कर रहे हैं?
हम find out कर रहे हैं probability.
Like the probability of, for example, अगर हमने हमें question में दिया गया है कि like probability of greater than 1.5, जैसा कि आपने पहली
less than or equal to 1.5.
Less than 1.5. So this shows that the probability of finding z less than 1.5 is 0.933.
Yeah, which means that the probability of being less than 1.5 standard deviation away from the mean is 0.9332.
Okay.
So how is it 9459? Won't it be 94? Oh yeah, 9429. Okay, sorry, I made a calculation error. Sorry, my bad. 9429. Thank you for pointing that out. It's 0.9429. Okay. Alright, now these are all the probabilities of less than. Okay, now dekho. Here the z value, okay, the area that you get is phi of z, which is basically the value that we get after reading the table, which represents the area up until that point. Okay, now if I want to find out the probability of greater than a certain value, for that what do we have to do? We have to subtract it from 1. So for example, if you're asked to find out the probability of z being greater than 2.5. Okay, now here it says greater than. Okay, now let's see what happens. Either way, we have to find whether it's less than or greater than. We have to find out the p value of 2.5. Okay, we have to find out the p value of 2.5. So we can do that easily since we don't have a lot of decimals. The p value of 0.25 is 0.9938. Now iska matlab kya hai? The p value or phi of 2.5 is 0.9938. Now what does this mean? This means that In fact, wait a minute, I have a picture of it. Just a minute. Yeah. So this is the normal distribution. This is the standard normal distribution, okay? The mean is at 0. 2.5 will be perhaps somewhere over here, okay? Now the p-value of 2.5 is 0.9938. Now what is this 0.9938 representing? 0.9938 is representing the area up until 2.5, okay? It's representing the area up until 2.5, which is 0.9938. But this is not what the question is asking for. The question is asking for the probability of z being greater than 2.5. So in this case, what are we going to do? In this case, we are going to do 1 minus 0.9938. Okay, so here, in order to find out this area, which the question is asking for this we will do 1 minus 0.9938. Let's see what that is. 1 minus 0.9938, that is 0.0062. 0.0062. Now what does this mean? Again, it's very important to not just find out the corresponding value, but also keep the meaning in mind. The meaning is that the probability of a value greater than 2.5 standard deviation away from the mean is 0.0062. That means not even 1%. Okay, and we find that we see the exact same observation when we look at the curve as well. Okay, so 2.5 standard deviation means, if you look at SAT scores, 2.5 standard deviations means somewhere over here. What do you think will be the probability of a student getting, let's say, more than 1550? Very high or very less? What would you say? Very high or very less? Very less, okay? And that's what we get. We get a probability which is very less. It's 0.0062, okay? So through this, we're able to come up with a standard rule that whenever you have to find out the probability of greater than, what you do is you do 1 minus phi of the corresponding value, okay? Now we're going to write down some standard rules. Once again, we put the theory on hold because we want to write down some standard rules. Once we have written those standard rules, then we'll look at an example question, okay? Your first objective, your first task is to basically learn how to read the z table, okay? And then only once you've understood how to read the z table will it make sense for us to do any example questions, okay? So we're going to write down some rules of normal distribution, which may or may not make sense right now, but once we get to example questions, they will make a whole lot of sense. Rules of normal distribution. Okay, these rules will tell you that when you have to subtract or when you have to take the value as it is, that's what you're going to do basically. So rule number 1, if you're asked to find out the probability of z being less than a, okay, a is just a random value. So what does this mean? This means that here is the curve, okay, here is 0, and somewhere over here is a. Okay, somewhere over here we have a. And in order to find out the probability of z being less than a, that means you have to find out this area, okay? Now, in order to find out this area, all we have to do is we have to read the phi value or the p value of a, and that will be our answer. Okay, so this is equal to phi of a, and just the phi value or just the p value will be the final answer. All right, so this is rule number 1. Rule number 2. Rule number 2 is, first let me write down the rule. If you're asked to find out the probability of z being greater than a, okay, so what do we do in this case? First let's see what does this mean graphically. So graphically this means that you want to find out this area. Okay, and we know that if we read the table, if we find out the phi of a, we get the area up until that point, area or the probability. We get the probability up until that point. But since we want the probability of more than, yes, that's correct. We do 1 minus phi of a. Okay, now just like this, we have around 7 to 8 rules. Okay, in fact more than that. We have around, now you can either memorize these rules or you can understand. Initially you might have to refer to them, okay, but with practice your understanding will improve, and then you can just figure it out there and then. Okay, rule number 3, if let's say you're asked to find out the probability that z is less than minus a. Okay, now keep one thing in mind, that this data distribution is what? Is symmetrical about the mean. Okay, so this data distribution is symmetrical about the mean. So here's 0, here is minus a, and here we have positive a. Now forget normal distribution for a minute. This is a symmetrical curve. Okay, think of it this way, that minus a and a are two x values. All right, now probability of z being less than minus a means we have to find out the area of this region. Okay, now what do you think about the area of this region? Will it be same or equal? We have to find out the area of this region. Okay, I'm asking you that what do you think about this? Will it be the same or will it be different? It will be the same. Okay, why? Because it's symmetrical. Now how do we find out area of this region? We find out the area of this region, as we saw earlier, by simply doing 1 minus phi of a. Okay, so that means if you want to find out the probability of z being less than a negative value, that means phi of negative a. So phi of negative a is basically the same as 1 minus phi of a. Okay, so finding out the probability of z being less than minus a is actually the same as finding out the probability of z being greater than positive a. Okay, why? Because it's symmetrical. Okay, how is it symmetrical? Once again, let's go back. So here's 0 and here's minus 1 and here's 1. What percentage of data lies 1 standard deviation less from the mean? 34.1. What percentage of data is in between 0 and 1 standard deviation from the mean? 34.1. Okay, so for that reason, because it's symmetrical, because the distribution is symmetrical, the area before minus a and the area after positive a will be the same. That means the area which is representing probability will also be the same. Okay, so that was rule number 3. Then comes rule number 4. Rule number 4 is, if you want to find out the probability that z is greater than minus a. Okay, so let's see how that works. Probability that z is greater than minus a. So minus a is going to be, let's say, somewhere over here. Now as per the question, you have to find out this area. Now, how do we do that? Here's how we do it. This, if we follow this rule over here, the probability of z being greater than a means 1 minus phi of a. So the probability of z being greater than minus a means 1 minus phi of minus a. And we saw earlier that phi of minus a is basically 1 minus phi of positive a. Okay, so this 1 minus remains as it is. 1 minus 1 minus phi of a. So what happens when we open the bracket? 1 minus 1 plus phi of a. So this gets cancelled, and now this becomes as good as phi of a. Okay, so if you're asked to find out the probability of z being greater than a negative value, you ignore the minus sign, you simply find out the phi of the value without the minus sign. That's your answer. Okay, now let me write down rule number 5. If you're asked to find out the z value of which is less than b and greater than a, so this is simple. What you do is you do phi of b minus phi of a. Why is that? I'll explain. So let's say here we have a and here we have b. Okay, so once you find out phi of b, you find out the area from the beginning up until the point b, and then once you find out phi of a, you find out the area from the beginning up until point a. Once you subtract the two, you're left with this region, the region that's in between a and b. Okay, and then from now onwards, I won't make the diagram, but I'll simply write down the rules. Okay, I won't make the diagram, but I'll simply write down the rules. So if you're asked to find out the probability of z being greater than minus a and less than b, the rule is phi of b minus phi of minus a, which means phi of b minus 1 minus phi of a. Okay, and then if you simplify, here's what you end up with: phi of b plus phi of a minus 1. Okay, so can we say the main concept is that we consider area to the left and just manipulate it? Yeah, that's what it is. Okay, so you won't even, like I said, initially you might have to refer to these standard rules, but once you've understood how it works, then you won't even have to refer to these standard rules. All right, now if let's say you want to find out the probability of z being greater than minus a and less than minus b, so for this, here's what we do: phi of minus b minus phi of minus a. Okay, like exactly what we did in rule number 5. Now because b is negative, how do we find out the phi of negative value? We do 1 minus phi of b. Okay, and the question is, why do we do that? Because in the z table you don't have any negative values. Okay, so when you do 1 minus phi of b minus 1 minus phi of a, here also you'll have to do 1 minus because it's negative. Then notice what happens: you have 1 minus phi of b minus 1 plus phi of a. So what you end up with is exactly the same, only slightly different: phi of a minus phi of b. Okay, rule number 8, last rule: the probability that the modulus, okay, or the absolute of z value is less than a. So in this case, first of all, what does this mean? This means the probability that z is greater than minus a and less than a. Okay, and in order to find out the probability that z is greater than minus a and less than a, we do phi of a minus phi of minus a, and we further simplify, we further open phi of minus a and write it as 1 minus phi of a. So phi of a minus 1 minus phi of a eventually becomes 2 phi of a minus 1. Okay, as far as the rules are concerned, we'll keep it. In fact, wait a minute, there's just one last rule. We'll write that down, and that's for the modulus of z is greater than a. Okay, so for this, the rule is, I'll just write down the rule. It's 2 minus 2 phi of a. Okay, we'll see. We've seen the first 3-4 rules. We see where they come from. When we come across questions where we have to use these rules, we'll see where these rules come from as well. Okay, now here is your task. Now from next class onwards, what I want you guys to do is, I want you guys to keep the z table in front of you. Okay, please get the z table printed, and I want you to keep it in front of you. The last rule, okay, I'll explain the last rule. Here we go. So if you want to find out the probability or the probability of the absolute z value being greater than a. Now first of all, what does this mean? Now in P1 we don't do modulus in detail. In fact, we don't do modulus at all. But for those of you who've done P3 would know that this is basically trying to find out the probability of z being greater than a and the probability of z, in fact not and, we'll use the word or, z being less than minus a. So technically, so we'll refer to the graph to understand this. Technically, what we're trying to do is, we're trying to find out the probability of z being greater than a. That means we want to find out the area of this region and we want to find out the area of this region. Okay, so how do we find out the area of this region? We find out the area of this region by doing 1 minus phi of a. Then how do we find out the area of this region? We find out area of this region is going to be the same as this one. Okay, so this would also be the same as 1 minus phi of a. And because in between the word is or, so what do? We add their probabilities. Now once you combine them, 1 plus 1 becomes 2, and minus phi of a becomes minus 2 phi of a. Okay, now there you go. Here are the last 3 rules. Yeah, you can multiply it by 2 also. Won't the area? No, area will never be in negative. Okay, why? Because the corresponding value is never negative. Okay, this is never negative, so it won't be in negative. And remember, you're finding out probability at the end of the day. So probability, as we know, is going to be in between 0 and 1.